What's review to today? I want to take a look at a hard Walmart SQL interview question hosted on StrataScratch.com. Let's get into it. Now this one's called median salary. Our task is to find the median employee salary of each department, and we should output the department name along with the corresponding salary, rounded to the nearest whole dollar. As I said, this one's asked by Walmart. It's also company tagged for Twitter or X now, and the honest company. We usually have several companies tagged for these questions. Now we have one table here called employee, which has employee information, an ID, for example, some descriptive information in terms of their name, age, and so on, and then the department, which was mentioned in the question, and their salary. And these are going to be the most important fields for this question, I feel like. Yes, so we're expected to find the median salary. This question is pretty much about calculating the median within a group, being the department. And yeah, looking at this question, I feel like we could do this the easy way or the hard way. And if you know the easy way, the question gets a lot easier. And if you don't, then it becomes very interesting, but also very hard. Now, in order to calculate the median salary, the easy way would be to know a function that actually calculates the median, knowing what the median is, and maybe how that can be expressed in another way. It's a good discussion for an interview question because it includes some sort of statistics knowledge as well. Now, another way to think about the median is to think about the 50th percentile, which is just another definition of the median. Median is defined as the 50th percentile, being the middle value in an ordered data set. So if you have a set of 7 values, maybe salaries for one of these departments, then take the middle value, the 4th value, if you order them by salary, and that's going to be your median. It's the value that has 50% of the values above it and 50% of the values below it. And yeah, if you think about it that way, then it brings you to the two solutions I have for you today. One of the solutions is just using a function to calculate the 50th percentile, being the median. The other solution is doing it by hand and doing this whole process I just laid out, with the special case of having an even number of values in your data set, and then there is no middle value, right? If you have a data set of 8 values, 8 employees with their salary in ascending order, then there are 2 middle values, pretty much the 4th and the 5th, and then you would want to have the value in between these two. So the median is defined as, or the 50th percentile also is defined as, the average of these 2 middle values if you have an even amount of values in the data set you're calculating the median for. So in this case, we would take the 2 middle values and add them up, divide them by 2, and would have the middle in between that, have the average, and that way we would calculate the median in this case. But we would have to transform all of this into SQL code to get this to work. So let's start the easy way and just calculate the 50th percentile with the function. So we're using PostgreSQL here, since it should be the most used out of these options we have here. We also have MySQL, MS SQL Server. But yeah, here we would take the department. Our expected output is the department name and the median salary, just 2 columns. And yeah, now we already need our percentile function. And since the median is defined as the 50th percentile, we will specify 50 in this function. So this is one of the percentile functions. There's percentile cont for continuous and percentile disk for discrete in PostgreSQL. And I'm going to use percentile cont here, because continuous here, because this one actually does the calculation if there is an even amount of values. It's just going to take the average of the 2 middle values, and that's exactly what we want. Okay, so we're in the shade now and can continue on. So yeah, we're going to calculate this percentile function, but we have to specify what it's based on. So in this case, we will base it on these groups we want to establish being the different departments. So we need to use the syntax of within group. That's going to be our department. And then similar to what we have in window functions, in that syntax, we specify the order we want to use for this group, for the window, if we're doing window functions. In this case, we want to do it by salary in ascending order or descending order. It doesn't matter for the median calculation, since it's always the middle values, but if they did the 10th percentile, something other than the 50th, it would matter here. So let's say we have salary in ascending order, so the lowest salary first, and do this for this group department. I'm going to select this from our employee table, the only one we have, and group by department. So what this code does now is it specifies that we want to calculate the 50th percentile or the median for each group being one department, because we have department in our group by statement, and calculated based on the order of salary in ascending order. Yeah, the percentile will also calculate or give us a salary value, because that is what we order. It takes this order statement piece and extracts the fields from that to calculate the percentile being the salary. That's the value we actually want. So we're going to calculate the 50th percentile of salary within each department as a group. That's the definition. And yeah, that should give us that. Let's run that code, see what it gives us. Yeah, actually there's a small mistake here. So we're supposed to supply it in this floating point form. So 0.5 or 0.50 to specify the percentile. And yeah, this gives us the correct values. Let's check the solution, see if it's accepted. It's actually accepted. That was the easy solution, as I said. It's quite quick if you know what you're doing. If you don't, it takes longer. And yeah, in this case, I use percentile cont, the continuous version. There's also a discrete version, percentile disk. And yeah, the continuous version does that average of the two middle values if there's an even amount of values. And the discrete version doesn't do that. I think it just takes the upper or lower value of those two instead of taking the average, and then that makes it incorrect. So for management, we get the incorrect value for one of the test cases. So I'd say you'd probably always want percentile cont. And then one thing that hasn't been covered by the test cases or with the example data here is rounding it to the nearest whole dollar, which would be just to wrap this with a round function. And yeah, you just wrap the entire thing and run it again, and it should be accepted again. Now that's the easy solution. Let's get to the hard solution. The logic is the same. We just have to piece it together by hand. Okay, I'm going to try to go over this quickly, but it is complicated, so bear with me. Okay, so we're going to try to do this by hand. So we're going to select the department, salary, each salary or each entry being one user or one employee. And then since we want to have these values in order and kind of want to take the middle values or the middle value if there's only one, we need to have some sort of order to them. And that's why I'm creating a row number here to number them in order. This is going to be our window function syntax. Partition by, order by. Partition by the department. Order by the salary ID. Let's also do ascending order here. And yeah, let's call that R. Just R, please. And we're selecting again from employee. Now let's see what this gives us as an intermediate solution. Salary ID ordered by the salary, sorry. And yeah, we have the department, 4 values for audit, 1, 2, 3, 4. In this case, we would want to take 2 and 3. And I want to be able to get these values with 2 and 3. Now, I don't really know how many values are in each department yet. So I don't know that I want 2 and 3 if there's 4. What I actually want is I'll take the highest value divided by 2, and then that will be one of the middle values. It will be 2. And then if I add 1 to that, I'll have the other middle value being 3. Then I want to add these two, divide them by 2, and I'll have the median value. In this case, I'll add 1,000 to 1,000, divide them by 2, and it's 1,000. In this case, they're actually the same, so it doesn't make a difference, but that's how you would do it. You could also use an average function, which might be easier, so let's keep that in mind. Now, in order to get the amount of entries per department, I'm just going to use a count function. So I'm going to count star or any of the fields, maybe ID. And in order to have that value as one of the columns here, but not just have one value for department or one row in the output for department, I'm again going to use a window function. So I'll partition by department. I don't need to order here because I'm just counting, and that should be fine. But I want a count of how many values are in each department. So I would want a column here that says 4 for each of the rows I already have. So that gives me exactly that. I'm just going to call it C, which is not perfect, but just keep that in mind. I have 4 values in management, and I have 22 in sales, which seems to be a bigger department here. Now this is awesome. This is a good base to work with. So I'm going to put this into parentheses, make it a subtable, call it ranked because it has the ranked values in there and also the counts. But yeah, just since I don't have a better name now. And now what I want to do is I want to select department. And now I want to have the logic for the median value. So I will say I want the average salary from this table here that's in the output below currently, but I want to filter it on only taking these middle values for the average. If there's only one middle value, then I'll just take that. Yeah, that's the logic I want to implement. So I'm going to select this from ranked, and now the where filter will have to have the magic to make that happen. Okay, so now for the final part, we're going to implement a where filter that includes a case statement. I didn't know you could do this before today either, but it's a very cool thing to do, and it is necessary to do the solution we have in mind. So we're going to specify that we want to express that when the amount of values in a department is even, for example 4, then we want to take the 2 middle values. Otherwise, if it's odd, just want to take this 1 middle value because there's just 1 middle value. So in order to check whether this amount of values is even, we're going to use the modulo function on C, or the operator, and do C modulo 2, which would be in this case 4, and then integer division with 2. And pretty much this calculation gives us the remainder of that calculation. So the remainder would be 0 if it's even. So if there's no remainder of that calculation by 2, that integer division, then it's an even value. And then if that is the case, we want to take both middle values. We get that by dividing C by 2. Now we know that C is even because we did this check here. If we divide it by 2, we get the lower middle value. So if we divide 4 by 2, we get 2. And then if we want to get the upper value, so R would filter R to this value, the lower middle value, or R could also be the upper middle value. And we could get that by either doing I think we could do c divided by 2 n plus 1, because this will still be an integer. This won't give us a float value, I think, but the better way to do this is to do c plus 2 divided by 2. So yeah, it's just gonna, well, I guess both works. So we're gonna do c divided by 2 because we know it's even, and then just add 1 to it. Yeah, this calculation should take place before the plus always, but we could also wrap it in parentheses. Yeah, even the order is same here. Yeah, let's do it. And then do the other case, which is that c is not an even number, which means it's odd. We take the middle value. Say we would have 5 employees in the audit department. We would want to get 3. 3 would be the middle number of 5 values. Now, in order to get that, we would, we would do c plus 1 divided by 2. So we know that c is odd, which means if we add 1 to it, it will be an even number. And if we divide that by 2, it'll be the middle value. So in this case, let's just do an example. If we take 5, add 1 to it, it'll be 6. Divided by 2, we have 3, which is the middle value. Now here, let's again wrap this to make sure. And yeah, this should give us what we want. So now, if you can still follow, we have this calculation. Basically, we have this table calculated in the subquery here. Then we take the department from that and the average salary per department, but we're just going to filter that to the middle values. And the filter works with a case statement that I need to end with an end keyword here as well. Specifies the end of that case statement. Yeah, so it's going to take the average value per department, but just taking the values that are the middle values based on this order, which is calculating the median in the end. Now, in order to get one value per department, we also need to group by department, and that should do the trick. Yeah, let's just check the instructions again. Department name along with the corresponding salary rounded to the nearest whole dollar. So we're going to round this as well, but let's just run it here to see if there's any issues. Case when, oh yeah, so this would be an else, sorry. Yeah, so case when C is odd, when C is even, and C is even, then we're going to take the 2 middle values. Otherwise, if it's odd, we take the 1 middle value, calculate by this calculation. Yeah. Now we get the same output. This would already be accepted, I think, but let's round it as well and check whether the solution is accepted. It is, yeah, just did that. Before I was just running the test cases. Yeah, so that's it, everyone. I said it was going to be hard, but it's good to get through that entire process and really understand the median and percentiles and these calculations. I didn't know you could use case in the where statement, which is very interesting, or just to use the count as a window function to get the count without just getting one entry in your output, but like all of the initial values and then also the count. And yeah, I thought about using a row number, but I had to look around some solutions to see how to actually bring it all together because it's quite a piece to do. That's why I marked this hard. I think it's cool to go through an actual interview. On the job, you would probably just use a median function or percentile function. And then you also always have the option pretty much to just do that calculation outside of SQL or SQL and just use Python or your dashboarding tool or whatever to get it. So yeah, give this one a try on StrataScratch.com. There are more solutions from users that are using a slightly different approach, which is interesting too. Maybe you can check it out and understand it or come up with your own approach. But that's been it for me. Check out the problem. I'll have a link down below. And if you get a subscription for StrataScratch through that link, you're also going to support the channel, which is always great. Apart from that, I'm going to see you in another video. See you there. Bye-bye.